So you are provided here with 3 different pieces to a function. And so we're going to write f of x. You should be doing the same. You don't have to graph this. You can see the graph up here. So how do you go about coming up with the equations? Well, let's just start and go from left to right. So this particular equation, I'm going to go through and I'm going to find good intersection points. Here's 1. I'm asking myself, where does it go? Directly through the corners. And we can see the pattern here, right? So let's continue that pattern. Going up 2, right 1, up 2, right 1, up 2, right 1. I'm not going to actually connect it. That would be only if I wanted this to go, this piece of the function to go throughout the entire Cartesian plane. We can see it only exists under certain constraints. So this piece, I'm going to write y equals, and remember it's going to be mx plus b. Where would this cross the y-axis? It would cross at a value of 1, plus 1. What is the slope? Well, to go from left to right, I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. This is the first piece. So I'm going to come over here and I'm going to write down 2 over 1x plus 1. All right, I'm going to do the constraints after I've come up with the equations for each piece. This next piece is just a flat horizontal line. A flat horizontal line has no slope, so it's y equals 0x, and we can see it crosses the y-axis at a value of 1. So yes, you could write y equals 0x plus 1, but we know 0 times any number is 0. We're welcome just to write 1. Let's go on here to this last piece. I'm finding good intersection points. Where does this line go? Directly through the corners. And now I need to continue that as it goes back down until it crosses the y-axis. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. And we can see this is where it would cross if I extended it. If I extended it, this is where it would cross. So it would cross also at a value of 1. So this particular equation is y equals, there's a plus 1 for the y-intercept. Now what is the slope from left to right? I'm up 1, right 1, up 1, right 1. 1 over 1x plus 1. 1 over 1x plus 1. Now those that may be very comfortable with this, you would know that 2 over 1 is the same as 2. 1 over 1 is the same as 1. Let's now do the constraints. I think it's helpful to actually cover this up. So this first piece is to the left of an x value of -1. So I'm going to come up here and I'm going to do x and -1. And now notice that this piece occurs to the left of -1. Think of this arrow as an inequality symbol. And it's an open circle. I'm going to leave it just as is. Now this is a little complicated. This middle section goes from -1 all the way to +2. Let's write down the smaller number, or the negative sign first, followed by the larger number. The x's are less than 2 but greater than -1. There is a closed dot at -1, so I'm going to put a line underneath. There's an open dot at 2. I'll leave it as is. All right, let's go on to the next piece. This next piece starts, if I cover this up, it starts at a x value of 2. So x and 2. And think of this as it goes to the right. This piece goes to the right of 2. This is like an arrow for the inequality symbol. There's a closed dot, so I get to put a line underneath. Here's example number 2. So the very first thing I'm going to suggest you do is we're going to start on the left-hand side, and I'm going to find good intersection points. So like it goes right through the corner. It goes right through the corner. So up 1, right 3, up 1, right 3. Keep going. Up 1, right 3, up 1, right 3. I'm not going to connect these. I'm not going to connect them. But what it's allowing me to do is I could come up with an equation of this. If I connected this, if I did, it would look like this. So I'm going to call this f of x. This particular piece of the function cuts through the y-axis at -1. And it has a slope from left to right of rise up 1, right 3. Rise up 1, right 3. We'll come back to the constraint later on. This middle piece, I can already see where it crosses the y-axis. It crosses at a positive 3. And it has a slope from left to right of up 1, right 1, up 1, right 1, up 1, right 1. Okay, this last piece, if you want to write 0x, you're welcome to, but I know 0 times any value is 0. It cuts through the y-axis at a value of negative 4. Now I'm going to go back, and you could have put down 0x minus 4. Now I'm going to go back, and let's look at this. So this first piece of the function only occurs to the left of negative 3. To the left of negative 3. So I'm going to do it to the left. Think of this as an arrow or an inequality symbol. So I'm coming up here. There's x and negative 3, and it occurs to the left. It's an open circle. I leave it as is. This middle piece goes from negative 3 all the way to positive 1. The smaller number must go first. And it's less than 1 and greater than negative 3. Now, both endpoints of that piece are bubbled in, which means we need to show that we're including them as part of the solutions to this, as part of the graph. And the last piece of this looks like this. It is going to the right. It's going to the right of positive 1. So x and 1, think of this as an arrow, this inequality symbol. It's an open circle. I leave it as is. So let's look at example number 3. This time we only have 2 pieces to this. So I'm going to start by going to the left, and I'm finding the good intersection points. Okay, those are obvious to see. So I'm going down 1, right 1, down 1, right 1, down 1, right 1. And I need to definitely go through until I see it crossing the y-axis. If you like to see the dotted lines like I showed in the PowerPoint, feel free to do that. Just don't connect them to make a straight line that's connected through. And the second piece, I don't need to worry about doing that because I can already see where it crosses the y-axis. So let's call this piecewise function f of x. This first piece right here would cross the y-axis at negative 1. From left to right, I go down 1, right 1, down 1, right 1, down 1, right 1. The second piece of this would cross at positive 3. And I go up 3, right 1, up 3, right 1. By a raise of hands, not even looking at the next 2 pieces, how many of you got these 2 parts right? It's okay if you didn't. Hands up. Okay. Let's go on to the next piece of this. Let's now put in those constraints. The first part of this goes into an x value, comes from the left and goes to an x value of negative 2. So I have x and negative 2. Now, from negative 2, this piece of the function occurs to the left. So think of this arrow as an inequality symbol. Here's the second part, and it's to the right of it. So we're at negative 2, and it's to the right of it. Think of this arrow as an inequality symbol, but I do have to remember that the top one had a closed dot, so I need to include that with the less than symbol, so less than or equal to. Let's get started with this one. So right here, we can call this g of x if we want, or f of x, whatever you prefer it to be. Here I have a horizontal flat line that crosses the y-axis at a value of positive 3. Now up here I have a diagonal linear line, and I can see it crosses at a value of 6. So it crosses at a value of positive 6 and has a slope of up 1, rise up 1, and run 4, 1/4 x. Don't forget about the x. Now notice that it splits at 0. So this first part is to the left of 0. Take this arrow, think of it as an inequality symbol. There's also a closed dot, we'll include that. The second piece is to the right of x equals 0. And it has an open circle. Did I do something wrong? What did I do?
The 1/4 x function a with plus 6.
Let's see, what did I do wrong?
Oh, sorry, I didn't check it out.
Okay, let's check. So do we agree with 6?
Yeah.
Yes? And then the slope is up 1, right 4, up 1, right 4. Does anybody do you understand that part? You feel free to always ask. What part of this can I re-explain?